Son las 4:30, empecemos. ¿Empezamos? Empecemos. Okay. Oh, that's too loud.
This is so much easier than that.
Ladies and gentlemen, and all other forms of being, I would like to draw your attention to something, and that is that last year, those who attended the SI session had, on average, 10 points higher final grade. One whole letter grade higher. Now, correlation does not imply causation. But ask yourself, would you rather be in the group that is getting a whole letter grade higher, or would you rather be skipping the SI sessions? We now have an SI, yay! And he's here to say a few words to you. Sahyu, come on down. Oh, come on, where's your applause? That's more like it.
Thank you guys for that. My name is Sahyu. I'll be your guys' SI leader this semester. You guys should have gotten an announcement from me earlier today on Canvas around 10 a.m. So we will be hosting 3 sessions a week. In those sessions, I'll just be going over course content. We'll work together, work through some problems based off of what you guys are struggling with. At the end of the sessions, I'll also have some time for you guys to ask questions, either things that we went over or maybe just questions about the class in general. The sessions will be Tuesday, Thursday. Those sessions will be 2 p.m. to 3 p.m. They'll be hybrid, so they will be recorded on Zoom, and they will also be in a location on campus that is still to be determined. So I'll send out an announcement once the room has been chosen, so that way you guys know where to go. And on Sundays, there will be from 12 p.m. to 1 p.m. a Zoom-only session. And so the first session will be this Sunday. So you guys are welcome to pop in, work through some problems. And like I said, all the Zoom recordings will be posted on the campus. So any questions regarding SI? There's my little spiel.
How much do you guys pay for tutoring from someone who the professor is literally saying, this guy just took the class, got a great grade, knows what he's talked about, works with me on making sure that it's synchronized with the class and everything? How much would you pay for a tutor for that? More than $0, I would presume. SIs are paid for by the university. So let me strongly encourage you, use him. Use him. Oh, let's turn this off. Yes, Auf Wiedersehen. Danke dir. Huh? Yes. Zoom with me. Yes. Yes, he is worth it. He is good. He is amazing. He is worth actually even more than $0 per hour. I know that the scheduling can suck. That's harder, but working with a small group of students who are going to get better grades, including you, because of it, and working through whatever challenges you may have in a small group, go to him for reals. I would love it if he had to get a bigger room because participation was on up there. That said, it is completely decoupled from my knowledge. I'm not actually allowed to know who's going or not going. I am not allowed to know who's talking smack about me behind my back. You can also go to relieve your emotional woes, and Sahyu won't tell me. I trust him. You could trust him. He won't tell me who hates me. You're allowed to go and complain about me. In fact, although no one has cause to complain about me or this course or whatever, I'm sure. Right, yeah. Being able to be in a small group of students and have an expert that you can share your woes is not a bad thing psychologically either. Okay, I have a Google Google form question. In Google question in Form A, someone just asked, do you have a study guide for the test? What's my study guide? The quizzes, that's right. The quizzes are problems which are intimately related to a good quarter of the exam questions on your midterm, which is coming up not next week, but the week after. Not Wednesday, but not next Wednesday, but the Wednesday after. 2 weeks from today. The midterm is largely made up of questions. They're not exactly, I don't want you guys to have to memorize. I don't want you guys to have memorization be the right way to do things. I want you to understand things. So they're not exactly the same questions. They're massaged, they're manipulated, but they're intimately related. You understand the quiz questions, you understand how and why they work, you'll kick butt on a quarter of the test. Where do the other 3/4 of the test questions come from? The homework. And you should notice that the quiz questions of the homework are intimately related. They're connected. So if you look at the homework, if you look at the quiz questions, and if you understand them and are able to do them without, for God's sake, Chegg, the interwebs, if you understand these things, you will ace the test. That's all I've got on the test. I don't make up any new problems for you. Everything is massaged, manipulated versions. I might ask for a different variable. I might change the numbers. I might flip signs here and there. You shouldn't memorize, but yeah. Another most common exam question. Yeah, you first. You can't get more points for them. It's 5% of the grade. But you should be able to review them. If you can't view a quiz, then I screwed up a setting. Just let me know and I'll fix it, okay? Other exam popular questions for exam coming up. What is my policy on note sheets? What can you put on a note sheet? Anything, everything. What size is the note sheet? Half a piece of paper. Front and back? Front and back. That's right. What kind of Scantron do you need to take the exam? Maroon. Can you get that at Tempe campus? That's right. You have to go to West Campus. It's like 25 cents. It's stupid. ASU doesn't charge you enough tuition, so we have you pay for your exam materials as well. It's kind of like paying for your own whip, right? Being beaten. Pay for this yourself. I'm sorry. It is insulting, but whatever. I'm sorry. I used to buy them for my students, then I taught 250 students at a time. And yeah, that's what I got. 2 classes of 100-ish. Okay, other questions, procedural questions, administrative questions before we get into content. You guys doing okay? Emotionally? No? Never better? I wish I could say the same. Oh, no, hold on. This is very important. This is very important. This is a crucial piece of the course material. I found this taped on my door when I came home. This is the thing I should have led with. This is taped on the front door when I came home yesterday. I know, right? I almost died. Almost didn't go inside because I just wanted to stay there. Okay, just wanted to share that with you. So we have 2 things to talk about today. We have 2 things to talk about today, content-wise, free fall and solving kinematics problems. You have actually been introduced to everything you need to do to free fall and everything you need for solving kinematics problems, but I've said it in passing. And one thing I have learned is that saying things in passing, the details don't get picked up. So I'm going to say the same thing 15 times. Let me tell you in advance, here is everything you need to know. Then I'm going to repeat it 15 times in different languages. Free fall, I define free fall. Free fall does not mean going down. Free fall means the only force is gravity. The only force is weight, is what I'm going to say. Gravitational force is named later. Nothing significant pushing and pulling on you. Yeah. Air may or may not be relevant to a given problem. If you've got a piece of tissue paper falling, that is not free fall because the force of air is comparable to the force of gravity. Air does jack to that. Air is insignificant, very small surface area, relatively large weight compared to the piece of paper. So air, you have to decide, does a parachutist fall in free fall? No way. The whole point of the parachute is not to accelerate, right? To fall in a way that the air can push on you and support you. I'm not going to give you problems where I say, you know, a beach ball is moving at 2 meters per second. Is this or is this not free fall? The equation to actually calculate air drag is complicated. We're not going there. I will give you something that is either a piece of paper is falling how much is it accelerating, or a ball is falling, and you can assume that sucker's dense. If it's not specifically something like a parachute or a ball or a parachute, a piece of paper, a leaf, you can assume that we're talking free fall. Capiche? Is good? Okay, so free fall means the only significant thing is gravity, weight force. Free fall has nothing to do with direction of motion. Falling in English means down, not in physicist-lish. Okay, so this is free fall, this is free fall, this is free fall. Going up is free fall, at the peak, turning around is free fall, going down is free fall. Because nothing was touching it, going up, turning around, or coming down. Only the planet was pulling on it gravitationally. The magical, simple thing about free fall is acceleration is constant in free fall. And the magnitude of the acceleration is 9.8 meters per second squared. For dog's sake, come on, there. In free fall, big thing to learn is the magnitude of the acceleration in free fall is 9.8 meters per second squared. And the direction of free fall, you'll be astonished to hear this, is that acceleration points downward. It's like gravity pulls us down. Big shocker there. I'm going to define, and your textbook uses the term G to refer to the magnitude there. G is not negative 9.8. G is the magnitude. G is 9.8. So you will sometimes see me refer to acceleration vector equals negative G. That's not negative. Right? Remember, magnitude means absolute value. Yeah. Weight, mg. Look at that. Questions on this? Okay, so does this acceleration formula have mass in it? You see kilograms in there? Heavy things and fall things. Heavy things and light things, if you can ignore drag, fall at the same rate. I've got a heavy thing, relatively. I've got a light thing. I'm going to drop them. They're going to hit the ground at the same time. Wait, what the heck? No, because there's a significant force of gravity. But if I change the surface area so that this sucker does not have a significant force of gravity, watch who wins the race. Which one got down first? Same speed, exactly same time, same acceleration, same everything. Okay? So to the extent that we could ignore drag, a beluga whale and these keys would fall the same distance in the same time. Please don't drop a beluga whale to test this. They're fragile to being dropped out a window. Okay? So a big heavy thing and a teensy tiny little thing, as long as drag is insignificant, they pick up the same velocity in the same unit time. They fall the same distance in the same unit time. Their acceleration is identical. There ain't no mass in this equation. Likewise, the direction of motion, going up, coming down. Do you see anything here about direction of motion? No. Going up, things slow down in exactly a symmetric fashion as when they come down, they speed up. Do you see anything about except when velocity is 0? No. At the peak of motion, now, at the peak of motion, something is neither moving up nor moving down. It is turning around. Remember, turning is a form of acceleration too. And your turning acceleration is still negative g, still negative 9.8 meters per second squared. If you are freely falling, if nothing else is pushing on you, nothing significant is pushing or pulling on you, then you are accelerating downward with magnitude 9.8 meters per second squared. Bang, that's it, end of story. Second thing, solving kinematic problems. There is one equation and 2 definitions in this course, in this whole module. Here we go. You should already know these. Here's the one equation. You want to find the displacement. If you could find the average velocity and multiply that by the time that velocity is acting, that velocity, average velocity is acting, that tells you how you displace. You must also define the meaning of any velocity. Oh, I should put, those are vectors. The meaning of any velocity is how rapidly the change in relative to the change in time, the change in position relative to the change in time, relative to time, and acceleration is defined as the time slope of velocity, how rapidly velocity changes. Okay, you can solve every problem in the homework with this idea and number and this equation and definitions. Bam, that's it. You can go home now. No, don't. Because in my experience is, what do they say? The devil is in the details. And not the happy, fun, has-been hotel devil either. A mean one. Okay, so let's let me give you some cheater ways to get around having to think about solving equations, multiple equations and multiple unknowns. First off, if you have constant motion, wait, I just said that. What if you have a changing motion? If you have a changing motion, then the initial t tells you how far you would go if you didn't change. Okay, that should be kind of okay. Now we need a term to show how the changing motion gives you additional or less distance, displacement. There we go. That's a very important formula. Displacement is VT. If you're moving steadily, you don't need to do anything. The initial t plus half acceleration times squared if you are accelerating. What happens if instead of v initial and acceleration, I tell you v initial and v final? If I don't tell you the acceleration, but I do tell you the initial and final velocities, what could you do? Bam! If you know the initial and final velocities, and you know you could find the average, bam, you're done. But if I tell you the initial and the acceleration, this can be useful. What if I tell you the initial and final velocities, but don't tell you time? Look, there's time, there's time, there's time. What if I tell you the initial and final velocities and stuff, but I don't give you time? Ain't nobody got time for that. Yes, there is time for that if you use the second magical incantation. You get an A. These are just algebraic rearrangements of these three shoved into various orifices of each other. Okay? There's nothing new here. These are just algebra, this plus algebra. However, solving two equations and two unknowns, based on my 3 o'clock class, I gave them a solve two equations and two unknowns, and they freaked out. If your algebra is not there, then these equations, additional rearrangements may be very useful. Hey, I'm curious. Let us see where y'all's algebra is. Let's talk about X and Y. Do you guys know the difference between X and Y? Did I tell you this joke? Do you know the difference between X and Y? A Y is an X that you can't even imagine dating again. Why a Y? Okay, anyway. I'm going to tell you y over x equals -10. And I'm going to tell you -1 equals half of y times x. Can you take these two equations and shove them in and solve for find x? Find x, it's right there. Okay. Google form. People are asking questions in a Google form B. Google form B, find x. Lots of people answered quizzes when I was prompting people to, yeah. I asked, what is the study guide? And people put quizzes in A. Okay, I'm training you well. This is what I generally want you to do, not in this case. Anyway, B, find X. You don't have to put quizzes in. It's okay. Okay. I'm just saying that's why I'm not using A, because many people already did. Okay, I'm looking for a number, by the way. Looking for a number, not an expression in terms of x's and y's. Solving two equations and two unknowns means you actually solve the equation. You don't just. I don't want a y, and I don't want an x when you solve for this. Give me a number. And this is Google question B, not C, please. One, two, three, four, five. Five corrects. Six correct answers. Siete correctos. Oh, you're God. You are? Ten. Once. Okay, again, I do not want an X or Y in the equation here. Turn to each other. I've got so far 12 people have got this right. Turn to each other. The answers are in front of you, sheeple. Look around you, sheeple. The answers are right there. But that's not what they say. They say, wake up, sheeple. Never mind. But talk to each other. Talk to each other. Help each other out with algebra. Ten seconds. Okie dokie, pokey pony. Time's up. The correct answer is 0.45. Square root 1/5. If you got that, give yourself a pat on the back. That was a quarter of the class. I think 3/4 of you raised your hands when I said you had calculus. This is algebra 2. Don't forget the simple stuff just because you've had the complicated stuff, okay? You didn't learn complex systems of two equations of two unknowns? Well, there you go. Okay, let me show you how to two equation and two unknowns. I strongly encourage the math in this class doesn't get simpler as time goes by. I know, right? So we've been dealing with fractions and subtraction. We're going to move on to algebra. We're going to be using more and more algebra, including systems. This is two equations and two unknowns. The more you do this, though, the more you revisit this, the more you'll get out of the course. So practice. Here, but I show you how to do. First off, the idea behind systems of equations is if I can solve for a variable, I can replace that variable in every equation. For instance, I can get y alone in this equation. What's y? Negative 10x, right? Multiply both sides by x because I hate sex. I hate x. Okay, now again, the principle of algebra is that if I know an expression for y, instead of writing y, I can write negative 10x. Let's do that in this expression, equation. I'm going to rewrite the same darn thing, except I'm going to write what y is equal to instead. Now, instead of two equations and two unknowns, I got one equation and one unknown. Once I find x from algebraing this sucker, I can shove him back up the first equation and find y. Bang, bada boom, bada boom. Okay, so follow up, how do I solve an equation for an unknown? First off, I simplify. I do not like this equation, so I'm going to simplify. One thing I could see that I could do to both sides is I can multiply by 2. That kills the fraction, right? If I've got 1/2 and I multiply both sides by 2, the half dies. Negative 1 times 2 goes by the name negative 2. Oh, look, I've got x times x. That's 2x, right? No. Squared. Squaring something is multiplying by itself. Adding something to itself is 2x. Okay, now I see negative 2 equals negative 10x squared. Can I make a simpler version of that? I would say multiply both sides by negative 1. Both sides are fully negative, flip signs. Okay, now I've got a 10x squared. Do I kill the 10 or do I kill the squared first? Are you sure? You divide both sides by 10. Yeah. But how do you know? Are you always sure that you're going to get rid of the multiplier first or the squarer first? Here's how to figure out which one you always do first. Whatever PEMDAS says, screw it, flip it. If you would evaluate the square, the exponent, before you would evaluate the multiplication, the 10, then do it in the reverse order that you would evaluate. I get rid of the 10. How do I get rid of a 10? Do I subtract 10? No, it's multiplying on, so I divide both sides. 2/10 equals x squared, or in other words, x equals 1/5. X squared equals 1/5. Now, how do I get the square away? I square root both sides. Square root of, well, it hurts my soul to write 2/10. Bam. Why didn't I what? Please, ask. Why didn't I divide by 2 to get the square off? Squaring means multiplying by itself, not multiplying by 2. So you have to root to kill a square. So then 1 equals 5x squared, but then I've still got stuff on top of the on top of the x. I want to get stuff away from x, like a jealous x. I want to get stuff away. Oh, I don't know. That's terrible. Let's not go there. Okay, how do you find y? I found x. Where's the y? I just take this and put her there, pal. Once you found one equation in a system of equations, it's easy peasy lemon squeezy to find the other. Actually, I should say, wait, shouldn't x be plus or minus? And then y be minus or plus? Properly for completeness, I should say that. Whatever, screw it. Okay, let's apply this to physics. Yay! How long did it take to fall? That's your problem. How long did it take to fall? Actually, you'll find out. You will calculate this. I am dropping this from a height of about a meter. Meter? I hardly knew. Meter? Yeah. Find the time it takes to fall 1 meter. Ready, set, go. You can do this with the equations that I done gave you. Google Form C, find the time. Which ain't nobody got. Which nobody ain't got. Which equation does it make sense to use here? What? Well, you tell me. I'm holding my hand about a meter above. What's the displacement then?
Wait.
No, it's not. Displacement isn't 1 meter. The distance it fell is 1 meter, but it did not displace 1 meter. You going down, son. I do not drop things and have them go up. I mean, I suppose you could do that with a balloon, but never mind. Do I have a question me? I want you to find the time it takes for my keys to go from my hands to the tabletop. How long does it take to fall 1 meter? Question. What did I ask? How long? What's a how long question? Well, I guess it could also be distance, but no. How long did it take to fall is a time. One meter? I'm asking a time, dudes. Again, my pregunta. La pregunta está. The question is, find the time to fall a given displacement. One of these equations connects the quantities that you now know about. Look at which equation connects your knowns and your unknowns. You have all the information given. It has all been explained today.
Try and see that one, but you don't understand it.
Pringle, by the way, is delta. Tringle x is delta x. Yeah, question. Nope. Acceleration. A is negative 9.8 meters per second squared. What is the initial velocity? Yeah. Who's guck? Which is how my baby says stuck. Who's guck? Who's guck? Utterly guck. Okay. So I will tell you, you've got the displacement. You've got the initial velocity. How fast is it moving the instant it leaves my hand? 0. Its initial velocity is 0 if I drop it. You have the acceleration from earlier in the class. This is the one and only connection that connects you with initial velocity, displacement, acceleration, and time. Plug into this dude. You can use any of these equations. You'll have to use 2 equations and solve a system, like we just practiced, if you use the wrong one. So you can always do these in 2 steps, picking any of them as the first step. If you pick this one, though, this is a one-stepper. It's already connecting only quantities that you have and one quantity which you don't. One equation and one unknown. Bang. SMS? What's SMS? What's meters per second? I'm asking for time, my friends. Time. Find the time. Again, there is no right wrong. There's a fast and slow. As you go through the entire year of physics, people in general take the scenic route. It's okay. Practice will give you intuition. This is Google question C. Are you putting it in C? In Spanish, the answer should be C. You get an A.
You know this equation right here, right?
Acceleration is 9.8 meters per second squared downward. Acceleration is negative g. Acceleration is negative 9.8. That's what the minus sign tells you. I can't hear. Please louder. Oh, sure, there will be cases. A rocket going up does not accelerate downward unless somebody has made a very big mistake. Somebody is having a very bad day if the rocket is only, always and only when something is freely falling near the surface of the Earth.
Yeah.
I mean, here's the equation.
Now we know.
That said, okay. There are lots of notations.
Like I did that way,
Mhm.
and it's more easy for me.
Sure. Notation, I don't care. I will never test you on.
We can make notations and.
Yeah.
values
As
on-
long as you know what U means and what VI means, then you will always be able to answer my tests. Hey, time's up. Let's do her. Let's do it together. I plugged in displacement -1 meter. He going down a distance of 1 meter. I plug in V initially is 0. I drop it. I drop it from the initial point is initial is 0 plus -9.8 times 1/2 is -4.9er. Now the next step I would do is kill the minus signs, divide by 4.9. And at the end of the day, I can escape that square by squirting it. Oh, my sweet baby Newton. Look, it's the same answer. It's as if I had an ulterior motive. What I demonstrated in the first, if you replace y with v and x with t, what our first warm-up exercise was this problem doing it in 2 steps instead of 1. Question me. Please. Final position, 0. Initial position, 1. 0 minus 1, final minus initial, -1. No, what does delta tell you? What is the meaning of delta? Well, delta x is displacement, yeah. Change in quantity. What is change compared to final? What's the difference between those things? Do you know what? Okay, change in something always means that thing's final value minus that thing's initial value. If I start with $900 and I end with $800, what's my change? Minus 100, final minus initial, 800 minus 900. I have earned a -$100. I've lost $100, right? If I start with $1 and I end at $0, what's my change? -1. Final value 0 minus initial value 1, -1. I'll write this down. Always, 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 always. Whatever you write after this, I could say x final, final position minus the initial position. Also, look back 1 week ago's lecture. The first half of the lecture was talking about displacement versus position. Watch that on YouTube. It's linked on the Canvas shell. And then ask me questions. Ask me questions before class next time, okay? Please. No. I used to, but there were too many student deaths seeing the algebra. He asked, am I going to derive these formulas, show how this algebraically follows from the other? And it takes more than 1 step, so people died. It was very sad. Okay. Part 2, part D, question D. Part D. Find the final velocity. Find the velocity at the time that it hit the ground. Sure. What do you know? What do you know?
Okay. Make sure. I had a feeling it was that, but I wasn't. Negative one? Oh, yeah, I got it went down. All right. Yeah, I had a feeling it was that. Who would it cancel again? Because it's the negative. Yeah. So yeah, it would cancel it anyways, because if you have the square, oh no, it wouldn't.
I got it, right?
The big hands? Oh, yeah, it would for the 9.8. I was trying to think of something else. All right, yeah, so say cancel that.
D, D, delta D, 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 not E. Give me the, never mind. Again, la pregunta, the question, die Frage, der Frage, das Frage. Question D is find the final velocity, the velocity the instant before the keys hit the table. Of course, once it hits the table, it slows down and stops. Not that.
Yeah, I think that's what I. 4.42. Wait, why did you grab that? I should have rounded up like that. I don't know why I. Sorry. I got the same number. I just rounded it up. That would be. That's a good question, actually. That's what, oh yeah, for velocity in your initial. Or final. Yeah. Yeah. Wait, no, that's still be here. Wait, I thought it was meter.
What am I talking about? It's a velocity. How do you measure velocities?
No, I just don't get it. What else? What's this whole number? What's this whole number? Thanks, bro.
That's right. So D is 50, right?
Hint. Who's Guck? People are progressing. Okay, so if you're Guck, here's a hint. Actually, for everyone who's done, also think about this. What does it mean to accelerate at negative 10 meters per second squared? What is the meaning of acceleration? One way to think about it, I'm going to answer my own question. One way to think about it is in 1 second, your velocity picks up negative 10 meters per second. In a second, my velocity changes by delta V is another negative 10 meters per second or negative 20 meters per second from the start. Your velocity goes down. If I drop this in 1 second, whoopsie, in 1 second, my velocity increases from 0 to negative 10 or whatever. If I throw it up with an initial of 10, in 1 second, I reach 0. From 10, in 1 second, I decrease to 0. Okay, follow-up question here. How long, roughly, is 0.45 seconds? Roughly, round the hell out of it. Half a second. 0.45 seconds is 0.442 seconds is roughly half a second. So if I pick up negative 10 meters per second in 1 second, how much do I pick up in half of a second? Roughly. Negative 5. Your answer should be close-ish to negative 5. Negative 5 meters per second in the first half second, negative 5 meters per second in the next half second is roughly negative 10 meters per second in each second. In other words, hint, your answer should be negative 5-ish. Now get the exact number. And I'll also do a calculational example up here. And that's enough time. I want to do more things than just this. Half a second. A is change in V over change in T. We just solved for change in T. So if I've got the acceleration, I've got the change in time, knee-jerk reaction. Acceleration time immediately links to, you got the change in velocity. Well, I get the algebra equation, negative 9.8 equals delta V over 0.45. I can algebraically solve for delta V by multiplying by 0.45 on both sides. And then I insert what the meaning of change is. Change in velocity is the final velocity minus the initial velocity. How fast was it moving at the beginning? So that just means V final equals negative 4.43 meters per second. Bang. Okie dokie. So close, but so far. Okay, there's another way to do this from scratch. And that is, you can use the equation V final squared equals V initial squared plus 2a delta x. How many of you tried this one? Great. Here's the way to do this. If V initial is 0, duh, right? A is negative 9.8. Delta x is negative 1. V final squared equals 2 times negative 9.8 times negative 1. I can simplify that. I think I can multiply negative number times a negative number. 2 times 9.8 is 19.6. And then I divide by 2 to get rid of the square. No. Wait, hold on a second. Think about this for a second. Squares kill the information about plus minus. Negative and positive, 5 squared is both 25. So if you've got x squared equals something, you don't know if x is positive or negative. You have to think about it. Final velocity, is it up or down? It's going down. So at the end of the day, you, when using this equation, have to insert the knowledge of which direction is sane for it to go. Yeah.
-4. That's still be correct.
Oh, no, to 2 sig figs, you probably should say -4 meters per second. Well, that'd be 1 sig fig. No, negative 4.4 would get full credit. I think in the homework system, it's if you're within 5%. In the quiz system, if you're within 5% of the precisest answer, it doesn't actually do sig figs. Ask me a question. Where are you stuck? Where are you guck? Turn to each other. Talk to each other for 10 seconds. Then ask me a question. Ready, set, go. When you have x squared equals 1, what's x? If x squared is 1, what's x? Not necessarily.
Oh, X.
What's -1 times -1? Yeah, so -1 or +1 both fit the equation x squared equals 1.
Oh, I see, because it's square root.
So if you are undoing a square, you don't know if it's plus or minus. The math itself, just the math doesn't tell you. You also have to use reasoning and say, is he going up or down when he hits the table? No, you have to insert that separately.
Have to like, because for this one, you just round up like one meter, but there be have to like.
Well, -1,
-1.
down.
Let's say take it from meters to feet.
Meters to what? Feet? No, screw conversions. If one of the homework problems has feet in it, just type into Google 190 feet in meters and it'll spit out the number. Conversions are good. Conversions are great. I want people to be thinking about the ideas. I'm not focusing on conversions in this class.
Wait, so you said it would be okay with 4.4 or does it need to be the 3
4.4 is fine. If it's within 5%, 4.4 is within 5% of 4.43. You will get full credit on the quiz system. Google me. No, not Google me. Don't Google me. Please don't Google me. Ask me a question. Please. Wait, say that again. Any sudden what? 9.8 meters? What? An area? Acceleration. Yes, you instantaneously start changing your velocity. Note, I said changing your velocity. I did not say your velocity becomes 9.8 meters per second. The instant I release something, it's not moving, v is 0. After 1 second, v is negative 9.8. After 2 seconds, v is negative 19.6. After 3 seconds, v is, I don't know, negative 30 something. Every second, your velocity changes by 9.8 meters per second. That's what acceleration is. It does not mean you are moving at 9.8 meters per second. What? Acceleration in free fall does not change. You're on a rocket, you better believe acceleration will change. The more fuel you burn, the lighter your rocket is, the more that thrust is going to accelerate you faster. A rocket will absolutely accelerate faster and faster as you go. For every problem we're doing, we're going to do steady acceleration. That acceleration will be in free fall, 9.8 meters per second squared downward. Whenever you're freely falling, you hit the ground, something grabs you, whatever, acceleration will jump to something else. But I'm not going to do steadily changing accelerations beyond scope of the class. Okay, so Google question E is what is the velocity of free fall? If I'm freely dropping an object, how fast does it move downward? Ready, set, go. Don't talk to each other. Question E, what is the velocity of free fall? How fast do things fall? Shh, no spoilers. Again, the Google question for Google question E is how fast do things fall? If I freely drop an object, at what velocity does it fall? Ten seconds. What is the velocity of free fall? What is the speed in the downward direction that things fall? Down. If something is falling down, I mean down. That's true.
Yeah, so because like in my high school when I used to solve the problems, they sometimes let me told me to take minus 9.8, sometimes positive 9.8. So that's my question.
Ask me in 2 seconds. 3/4 of you are wrong. I lied to you. The correct answer is it's a trick. The velocity of free fall doesn't exist. There is no velocity of free fall. If I drop something, its velocity changes. You never have, for an instant, a freely falling object will be moving at 9.8 meters per second downward. For an instant, after 1 second of being dropped. It will not stay at that velocity. Things do not move steadily in free fall. Okay? The instant you drop them, they're not moving. After 10 seconds, they're trucking. They're moving a football field every second. In free fall. Question. Terminal velocity only applies if there's more than one force acting on the object. Terminal velocity results from air drag. It is not free fall. If there's terminal velocity, we're not talking about free fall. Okay, ask me your question again.
Velocity of the object.
In which direction will be the velocity of the object? Well, you have got to ask yourself, is the object moving upward or downward? If the object is moving upward, I would choose a positive velocity. If the object is moving downward, I would choose a negative velocity. Which direction is the acceleration always down? It just, I mean, assuming that you're picking this as your coordinate system.
So when we incorporate the values, formulas
Mm-hmm.
will always be negative 9.2.
Well, look, position, velocity, acceleration, all kinematical quantities depend on your coordinate system. If I'm talking about left-right motion, what's the gravitational acceleration? Gravity doesn't accelerate you left-right, 0 in the left-right coordinate system. You are free to say down, distance fallen is your positive distance. If you're a skydiver, maybe this is relevant. How far you have fallen is maybe a more interesting distance displacement. In that case, gravity is in the positive direction. What I'm doing, for simplicity's sake, is universally saying this desk height is x equals 0, and this is the positive direction. Gravity always points towards the center of the Earth. As long as your position increases as you go up, gravity is negative.
If we are going up, let's say we throw a ball in the sky, the velocity will become 0.
Now, yes, it absolutely did become 0.
Because it becomes 0, the acceleration is negative.
Velocity went from a positive number to a 0 number to a negative number. Those are negative changes, absolutely. You're subtracting off of a positive number to become less positive, to become 0, to become negative, to become more negative. The changes are negative. The acceleration is negative. Same thing in 5 ways. Okay, so again, if I ask you, what is the velocity of free fall? What you going to say? There is none. Things don't fall steadily. Not in free fall. This is not free fall. There might be a constant velocity there. That's not free fall. If I am freely falling, if air drag is negligible, what speed does that hit the ground with? Not 9.8 meters per second. It is accelerated so that each second the velocity changes by. You got to actually do the calculation to find how fast that's going when it hits the ground. Oh, that's what we just did. That's how to do that. You pluggy into calculating. Is good? Last chance for questions before I move on to some other practice questions. Yeah.
There is no initial velocity when we do it, we still put it in, right?
For V initial, if you are dropping, releasing from rest, you betcha.
Just because there's nothing.
It's not moving up. It's not moving down. It's neither positive nor negative. Yeah. What's halfway between plus and minus? It's 0. Okay, so Google question. Use the formulas, Luke. Google question, what are we on? F? I love James Bond movies. James Bond is holding a briefcase full of Russian nuclear secrets. He's grabbed onto a helicopter skid, bottom of a helicopter. It's taking off. It's getting faster and faster. It's at some instant, it's moving at 5 meters per second. 5 meters per second. It's also accelerating, but screw that. At some instant, it's moving 5 meters per second. Hey, if James Bond drops the suitcase while moving upward, does it instantaneously start moving downward? Its instantaneous acceleration is downward. Its upward motion slows. If you are going up and release something while it's going up, look at my hands. Didn't the keys go up a little bit before they came down? The initial velocity is 5 meters per second. Things have inertia. Velocities can't change instantaneously. Gravity doesn't mean that things fall instantaneously at 9.8 meters per second. It means that it changes your velocity at 9.8 meters per second for every second. If you are moving up at 5 meters per second and release something, it is moving up at 5.8 meters per second. Question? Inertia is the idea that things don't change their velocity instantaneously. Things like to keep moving as they are. So if you release the briefcase while everything is moving upward at that time, 5 meters per second, its initial V is +5. Splash! James Bond hears the briefcase hit the water. Oh no, those nuclear secrets. Hits the water 5 seconds later. I like the number 5. How high was the helicopter at the time he released the nuclear secrets? Google question F. Again, I'm telling you, he released the briefcase while at that instant, the helicopter was moving upward at 5 meters per second. And it took 5 seconds between that time and the splash. Find the initial height of the helicopter. Find the initial height. Did I see a hand up? Yeah. That's what I would say. I would set the sea level as 0.
Yeah, 5 seconds.
That's the same question you just asked.
Yeah.
Really?
Yeah. What do you think is different?
I thought would be the height, like, he dropped it, right?
Uh-huh.
And then the helicopter is still moving up even.
It is.
So what's the height of the helicopter?
No.
I thought that.
No. What is the height? At what height did he release the briefcase? I could also ask, at the time it hits, where's the helicopter? That's not what I said. Find the initial height.
Big upwards and 5 meters per second velocity.
And if you release something while going upward, it will instantaneously still be moving upward. And gravity is going to change that initial velocity. But at that instant, it starts up, it's going to stay up. At that instant, it will be up.
Okay, hang on. So you is 5. Oh, wait, no, it's a change in, the X. But that's it, 5 seconds. Okay. Yeah, like I said, all those numbers are.
I like 5s. This is F, not G, please. Why not? G, if you're already done, find the final velocity. No. Oh, sorry. Look at your equations. Use the equations, Luke. All you have to do is plug in and plug and chug. Say that again? I mean, two situations.
So when the height moving up, it's like 5 meters per second.
Mhm.
When we drop the, so wouldn't it also, so wouldn't the motion be like, the motion of the bag be like this?
One equation describes both up and down displacements. You're right for the first half a second. The object will be still moving upward. The position, the displacement will still be positive. You plug in bigger and bigger and bigger t's, that displacement will go negative. One equation suffices. Gesundheit. That's what you're solving for, dude.
Because I tried it this way, and I got this one. And then, yeah, but then it's still not right. Yeah, that's 25.
Where'd you die? Your face does not like this. Where'd you die?
Getting, like, I did it. First time I did it, I did it in like 30 seconds, and I was like, oh, cool, and then I got -97 on it.
That's the displacement. You go down a distance equal to the height. The height is not underwater. Ow. Question me. Sea level, I call that height 0. Where does it hit the water? Isn't that the bottom of your coordinate system usually? No, you're dropping the briefcase, but I said the final, what is happening at the final time is the briefcase hits the water, not the helicopter. We're out of time. Adios. Love y'all. Bye. The initial height of the helicopter based on information about the briefcase. You could also say the initial height of the briefcase. Where is the briefcase being dropped from? From the helicopter. So the height of the helicopter is the initial height of the briefcase.
Well,